Okay, this is going to be part 1 of your review. You're going to have a little quiz on Monday, which I posted on Edsby. And so to get you ready, we're going to do a review of section 6.3, 5, and 6. So for today, anyway, I'm going to do 6.3 and 6.4. And then on Thursday, we'll do 6.6 and wrap up any questions on any particular subject or topic you have. It's going to be your job in the meantime to go through these things and say, hey, can you give me a few more examples on this thing, or I need help on that thing, all right? And I will respond, as you know, right away pretty much. Okay, so we're going to start with 6.3, which is vectors in the plane. And again, this is a review, so you can go back and watch the other videos if you're a little bit stuck on something or if you don't remember. All right, so these are the topics that I'm going to cover, so I broke them down short and sweet, and I'm going to include some examples, and what I have is the ebook behind me. So I'll move this screen over to the side when we're ready to do some examples. So the first thing you're going to have to do is determine whether or not two vectors are equivalent. And if two vectors are equivalent, remember they're going to have the same length or magnitude and the same direction or the same slope. Okay, these things mean the same thing. All right, so remember to find the magnitude of a vector. You're just really using the distance formula, and if you want to call your points x, y, that's fine. X2 minus x1 squared plus y2 minus y1 squared, all under the square root, is the distance formula. And if you want to find the direction, then you're going to check the slopes, which is just the difference in the y's over the difference in the x's. Okay, so a simple example is example number 12. Bring that up here. So in this exercise, again from the book, they want to know, are these two vectors that are given equivalent? All right, so here's the vectors here for number 12. U has initial point 2, 0 and terminal point 7, 4. And V has the initial point negative 8, 1 and 2, 9. So if I want to figure out whether these two vectors are equivalent, the first thing I want to do is find the magnitude. So the magnitude of U is just going to be the square root. Let me get a different color here. So it's the difference, if you look in the formula, it's the difference in the x's, right? So you have to think of this as x, y, okay? So you can do 7 minus 2 squared plus, and then the difference in the y's, 4 minus 0 squared. You have to maintain the same direction, right? And so, cleaning that up underneath, we've got 7 minus 2 is 5 squared, plus 4 minus 0 is 4 squared. And I'm just going to write this down here. 5 squared is 25. 4 squared is 16. So 25 and 16 is the square root of 41. And that's it. You wouldn't have to, I mean, you can't simplify that. You're done. That's the length of the vector. If, I had my calculator, which you all will have, you can't simplify that, but to get an idea, maybe if you're wanting to know the length and you have the units, you could just pop that into your calculator, and maybe this is in centimeters or something, then you can get an idea that's about 6.4 centimeters. But that's it, you're done. You found the magnitude. So you found the magnitude of U, now you're going to find the magnitude of V, because they have to be equal. So I have to do the same thing with these points. So remember, these are initial and terminal points in that order. So if I take the difference of the x's, 2 minus a minus 8. Now here's where you're going to be really careful with your signs. Right? Plus y minus y. And if I clean that up a little bit more, this is going to become 2 minus a minus 8. It's going to be 2 plus 8, so that's 10 squared. Plus 9 minus 1 is 8 squared. And 10 squared is 100. and 8 squared is 64. So I get the square root of 164. That's a 6. Right away, I can stop because the two magnitudes aren't even the same. So if you're taking a quiz or a test and either the magnitudes are not equal, or maybe the magnitudes are equal and then you get down to start working on the slope and the slopes are not equal, well, one or the other, you can stop right there and say they're not equivalent, because both have to be true. The magnitudes have to be equal and the slopes have to be equal. And just for a little bit of additional practice, let's just look at the slopes. The slope of u is going to be 4 minus 0 over 7 minus 2, which is 4/5. Right? Change in y over the change in x. The slope of v is going to be 9 minus 1 over 2 minus a negative 8, which is 8 over, remember that's going to become a plus 10. If I reduce that down, 2 goes into 8 4 times, 2 goes into 10 5 times. So look at that, my slopes are the same, but my magnitudes are not, and therefore I would say these vectors, I could say vector u does not equal vector v. Alright? And I don't know if that's for the one above it, I guess. And I guess there's not an answer for that one. But anyway, you can check it out. Okay, now that that's done, we can look at the component form of a vector. The other thing you're going to have to do is you're going to have to find the component form of a vector. You're going to have to find the magnitudes and of that, which is even easier than this. It's a lot less work. So what is the component form of a vector? A vector whose initial point is at the origin, right? A vector in standard position. So remember, if the vector starts at 0, 0 and goes to some point here, P, then we call this vector a vector in standard position, or a position vector. Okay, the nice thing is it can be represented just by its terminal point. So let's just call this point xy. We know this point right here is 0, 0, this initial point. So x minus 0 gives you x, and y minus 0 gives you y. So we can write the component form of the vector as long as the initial point starts at the origin. It's going to be the same, the components of the vector are going to be the same as the coordinates of the point of the vector. Alright, so usually you'll see, you know, u is denoted with these pointed brackets, right? Whatever your components are. You have component 1 and component 2. And same thing for v, or whatever they call it, right? We call it v sub 1, v sub 2, and so forth. And then don't forget, we have that 0 vector whose components are 0, 0, which means it has 0 magnitude, 0 direction. Now, in component form, we want to know the equivalence of these vectors, and two vectors are going to be equal if and only if you're given two vectors, say u and v, with those components, if and only if their components are the same or equal, okay? So the same components. So if I said, you know, u is 1, 3, and vector v is 1, negative 3, are they equivalent? You would say no, because while the first components are the same, the second components are not the same. So they would have to be identical. If I said u is equal to 2, 4, and v is equal to 2, 4, then I could say yes, those are identical vectors. They have the same exact components, so they're really easy to spot. Now, if I want to write a vector that's not at the origin in component form, then guess what? I'm going to have to subtract the x's and y's, or p's and q's, or whatever you want to call them. So suppose we have some point p sub 1, p sub 2, and some other point q sub 1, q sub 2. We're calling p sub 1, p sub 2 point p, and point q would be have the coordinates q sub 1, q sub 2. Likewise, I could say point p is at, you know, x, y, and point q is at x2, y2, or something like that. Doesn't matter. If I want to find the component form of the vector, then all I have to do is subtract the p's and q's. So I would do q sub 1 minus p sub 1, and q sub 2 minus p sub 2. And you notice I've got the pointy bracket, so when I do that, I'm converting this into component form. And we call that vector v, or whatever name you want to give it. And the magnitude of this is really nice because all you do is take the components and square it. Add them together and take the square root. So if I scroll up here, I put number 20. Let's find number 20. They're giving you an initial point and a terminal point, and they want you to write the component form. Find the component form of a vector. Okay? Number 20 is right here. So let's do it. We have the initial point of negative 2, 7, and the terminal point of 5, negative 17. The first thing I want to do is find the vector, so I'm going to call it v. Okay, and all I have to do, right? So again, remember, I'm taking the components have a specific sequence to them. So I'm taking the first component of the terminal point and subtracting from it the first component of the initial point. So I'm going to take the first component of the terminal point and subtract from it the first component of the initial point. So this would be 5 minus a negative 2, comma, and then for the second component I would do negative 17 minus 7. Same direction. And now I'd want to clean that up. So 5 minus a negative 2 is 5 plus 2, right, or 7. And negative 17 minus 7, remember, if you have to, change this to a plus and put your little minus there. If the signs are the same, you add and keep the same sign. So negative 17 and negative 7 is a negative 24. This would be my vector in component form. Alright, vector operations. You need to know how to add and subtract. So, if you're going to add, you add the same components. If you're going to subtract, you add the opposite of the same components. And if you want to multiply by a scalar, a number, you just multiply the scalar directly in. So in number 32, let me move this down a little bit. What you want to do is find u plus v, u minus v, and 2u minus 3v. So let me write that down. We want to find u plus v, I want to find u minus v, and we want to find 2u minus 3v. So those are the things we want to find given the component form of these two vectors, where u has components 2, 3, and v has components 4, 0. So if I want to use u plus v, well, that means I just add the corresponding components. So I'm going to do 2 plus 4 is 6, and 3 plus 0 is 3. I'm done. If I want to do u minus v, remember, it's easier to rewrite this as u plus the opposite of v. So you could think of this as 2, 3 plus, now if you take the opposite of v, that's negative 4, 0, right? You just change the signs. And again, I'm going to combine the same components. So 2 plus a negative 4 is a negative 2, and 3 plus a 0 is a 3. That's u plus, or sorry, u minus v. Finally, if I want to do 2 times u minus 3 times v, well, now I'm just multiplying a scalar. So a scalar is just a number. I'm multiplying 2 times the components of vector u minus 3 times the components of vector v. So I've got 2 times 2, 3 minus 3 times the components of v. Right? So if I multiply this in, it's the same as like distributing, right? I'm going to multiply this 2 to every component, so I'm going to get 4, 6. Okay. Now you can change this to a plus and make that a minus if you want. So I've got plus negative 12, 0. Again, I'm doing negative 3 times 4 is negative 12, negative 3 times 0 is 0. And now I've just got to combine the components. A positive 4 and a negative 12, the signs are different, so you subtract and keep the sign of the bigger number. So we're going to have a negative 8 and 6 plus a 0 is 6. And you're done. Okay, so you're going to get some more practice on these things. Well, hopefully you'll practice. And, you know, you'll know what you are having trouble with by Thursday. So hopefully you watch the video. You go in and you do a little bit of practice, and you let me know right away what you do and do not understand. Okay, this one was probably, so given the feedback I got on the homework and the messages I received, this right here was probably the biggest issue of any of it. There were a few little quirks with the distance formula. Some of you need to work on your pre-algebra skills, the distance formula and the slope formula. You need to really make sure you know that. But it was here that you didn't understand what to do. So there's a rule. And the rule says that if you multiply a scalar, so I'll call it A, some number, times a vector, then what you do is you take that scalar out in the absolute value because it has to be positive. Because remember, magnitude is length, so you can't have a negative length. So you have to make sure you take the absolute value of the scalar and then you multiply that positive number by the magnitude of the vector. So here's an example. Find magnitude 3u. Well, all you have to do, 3 is the number, that's the scalar. So you notice I pulled the 3 out in absolute value symbols. Now, I didn't have to put the absolute value symbols because I know the absolute value of a positive 3 is a positive 3. Remember, the absolute value is just the distance from 0 if you think about the number line. So, again, we're working with length, so we want to make sure our number is positive. But anyway, we have 3 times the magnitude of u. So the absolute value of 3 is 3. The magnitude of u means I take the components of u, I square them, I add them together, and I take the square root. So I've got 4 squared plus negative 1 squared. That gives me 3 times the square root. 4 squared is 16, negative 1 squared is 1. So I get 3 root 17, and I'm done here. I can't simplify that anymore. Here's another one. Now I've got the magnitude of negative 2v, so now the number is negative, right? So it's crucial that I take the absolute value of it. So you pull the negative 2 out, put it in absolute value symbols, and you're going to multiply that result by the magnitude of v. Well, the absolute value of negative 2 is positive 2, and the magnitude of v just means that I take the square root of the sum of the squares of the components of v, meaning I do 3 squared plus 2 squared under the radical. If I square 3, I get a 9. If I square 2, I get a 4. 9 plus 4 is 13. It cannot come outside of the radical. It's not a perfect square, and so you're done. That's it. It's really very simple. So if this was the one thing that like drove you up the wall or whatever, then do some more practice in this section and that will help you. Alright, so that's it for 6.3. Now I'm just going to do 6.5 because it's a pretty quick section, and again I'll save 6.6 for Thursday, so I'll let you digest this and get some practice in. The complex plane. So remember, we have complex numbers that are represented as z equals a plus bi, and that's called a complex number in standard form. A is the real part of the number, and b is the imaginary part of the number. In the plane, you remember this as x, y, right? Horizontally, we go on the x, positive x, positive y, negative y. Well, now it's r for real and I for imaginary. So the real part, the positive real, is to the right of the origin. Negative r is to the left. Positive imaginary numbers are above the origin, and negative imaginary numbers would be below the origin. So if I asked you to plot something like z equals negative 2 plus I, that means you would start at the origin. You always start at the center, right, at the origin. You'd go over 2 in the real direction. And remember, think of this as a 1 in front of it, like a coefficient. And you're going to go up 1 in the imaginary. So you go over 2, up 1, and you plot your point. And there's your complex number. That's it. Now the modulus or the magnitude of a complex number is just its distance from the origin to the complex number in the plane. So I don't know what this is. If I had a ruler, maybe I could measure it, but this has some distance between the origin and the point, and that's called the magnitude or the modulus. And the modulus, because it's distance or length, has to be the absolute value. You cannot have a negative number. All right? How do we find it? The same way we found the modulus for component vectors, or the magnitude. It's just real part squared plus imaginary part squared. All right, so let's see, I think I wrote down, oh, I didn't. So let me go in the book here to 6.5 exercises. And let's see what they got here. Let's see, so here's some plotting, which you guys did very well in the homework. Okay, so here's some. So they're saying find the absolute value or modulus, same thing, of a complex number. So let's look at number 17. The complex number is -6 plus 8i. Okay? If I want the modulus, the first thing I'm going to do is I'm going to put my absolute value symbols around it, and I'm going to say that equals the square root of -6 squared plus 8 squared. Popping that in and squaring it, popping that in and squaring it. Well, -6 squared is a positive 36, and 8 squared is 64, and 36 and 64 is the square root of 100, and you know that the square root of 100 is 10. So the length of this thing is 10, and if I wanted to think about it, I need a little bit more room here, so if I were to plot this complex number in the plane, I'd go over -6 and up 8. So here's my number, right? Z equals -6 plus 8i. There's my complex number. So what this 10 is the distance from the origin to that point. If I took a ruler and measured it, it'd be 10 units long. Okay, it's very, very simple to do that. Just take the real and the imaginary parts, square them, add them together, and take the square root. And by the way, if you had some imaginary number that you ended up with root 13, well, then that's your length. Okay, the final part is operations with complex numbers, very similar to operations with vectors. If you want to add two complex numbers, you just add the real parts and then add the imaginary parts and then write the final answer in standard form. Example, I want to add these two complex numbers. I do 2 plus 3 is 5. 4i plus 1i is 5i. I'm done. That's my complex number in standard form. Standard form says real plus imaginary in that order. So that's it. Maybe I would want to do, so I'll come down here for a second. Maybe we want to do, 4 plus I plus I. Well, hey, I've got a real part and an imaginary part here, but only an imaginary part here. No, you have a real part here. It's just 0. So if that happens, do this. You see that? And now add the real pieces together. Well, 4 plus 0 is 4, and I plus I is 2i. And you've just added your two complex numbers. If you want to subtract, then again, you can change it to the opposite if you like. So you're still going to combine the real and the imaginary parts, but if this minus in between bothers you, what you can do is change this to a plus, but change the signs of everything in the parentheses to the right. So what I mean by that is, here I just quickly added, 4 minus 3 is 1, and 2i minus a minus I gives me 3i. But some of you are still kind of rusty with signed numbers. So if you have to, you can write 4 plus 2i plus, now look what I'm doing. The minus is out here, but I'm changing it to a plus, and all I'm going to do is rewrite what's inside, like so. All I've done was change the signs of what's inside. Alright, so now what I have is 4 plus a negative 3, which is 1, and 2y plus I is 3i. So I'm going to get the same answer. Alright, I'm still combining the real parts and the imaginary parts, but some kids don't like that sign there, so put a plus there and just change the signs of what's inside. Here's another one. Let's do, I don't know, 3 minus 2i minus 6 plus I. Again, I can rewrite this as 3 minus 2i plus negative 6 minus I. So again, I changed that sign in the middle to a plus, and I just changed the signs inside the parentheses to their opposites. So now if I combine the real parts, I get 3 plus a negative 6. When the signs are different, you subtract and keep the sign of the bigger number. 6 is the bigger number, it's negative, so my result is negative. And I have negative 2i plus a negative I. When the signs are the same, you add and keep the same sign. So 2i plus I is 3i. The signs are both negative, so I keep the same sign. Alright? And again, if you don't want to do this, because I don't, but and if you're comfortable with that and it works, then use that. But if not, you know, I just do 3 minus 6 is negative 3. Negative 2 minus 1 is negative 3. So it's just sort of like, you know, another way you can think of it, but you can't write it this way, is if you had, say, you know, 3 minus 2x minus 6 plus x. Think of any number in front of that x as a coefficient, right? You do the same thing with the I. Think of I as a variable almost. It's not, but think of it like that. And if you were to combine these, you know, you have, again, if I change the signs inside, you would have 3 plus a negative 6, which is negative 3, and then you know that negative 2x plus a negative x is a negative 3x, right? So again, if it helps you to think in terms of that, do it. And if not, then, you know, do more practice with what's given. That's it for 6.5. All right, so it was pretty much just finding the modulus and let's see, plotting the complex number in the plane, determining what the real part is, the imaginary part, and then adding or subtracting two complex numbers. So that's it for this part of the review. I'm going to post your homework in WebAssign, and in fact, that kind of actually worries me, only because you know, I have it randomly assign problems, so if I do that again, like, I'm not going to go through the last assignment and say, oh, I already assigned that one, because then I've got to go through those problems, and every kid has different problems. So they're the same concept, but they're different numbers. So I don't want to go through, I don't know, I have like 60 of you guys. I don't want to go through 60 individual homeworks to figure out which ones were assigned and which ones weren't. So rather than that, what I'm going to say is, how about we do the following? So the homework, or the practice, okay, not homework, but review practice. What you're going to do in your notebooks or whatever, as you're going to do, you're going to go to page page 425. So this is for section 6.3. You're going to go to page 425, and what I want you to do is number 10, number 14, number 16, number 22, number 34, 36, and 40. Now I know, oops, sorry, I'm going out of focus here. I know that seems like a lot, but remember, this is practice. This is to help you. So, you know, you start plowing through these and yeah, those are no problem. Uh-oh, I'm stuck here. I kind of don't know what to do. Put a star by it or circle it. And then you can say to me on Thursday, you can send me a note, a message through Edsby and say, you know, I need help with number 34 or I need help with number 40, whatever it is, okay? Before Thursday. So that way I can send you a little video, because that's what I do. I get a message. Ask the Calc kids. I get a message and within 5 minutes they get a video of step-by-step the solutions. I work them all out. So, you know, if I have 40 kids all at once sending me the same, you know, different messages, then you go into queue. In other words, I do first come, first serve, but still, I'm pretty quick with it, and it's very helpful according to the calculus students. So keep that in mind. Let me know right away if something is bothering you or you cannot solve it. Then in 6.5, 6.5, which is on page 443, I want you to do number 8, number 16, number 18. I want you to do 22. I want you to do 30. And that's it. Oh, wait, let me make sure. Yeah, I forgot to talk about complex conjugates. So I'll include that in the next video. Alright, so the idea is this. If you get all these, then you don't have to practice them. You go to this section and you try those. These last few are addition and subtraction. And by the way, you know, 30 through 36 is all addition and subtraction. So if you get messed up because of signed numbers or whatever, then do all of the evens and say, hey, can you know, I got this answer for number 36. Can you tell me if I'm right? Sure. All right. So again, I'm not here to like do homework for you. I'm here to guide you and give you a little bit of help to kind of prod you to think for yourself and get the job done. All right. And if there's more of an in-depth issue where you need more help, then I'm more than happy to do that. All right, but some kids, they say, oh, you know, I don't get number 7. Can you do number 7? Well, what they want me to do is do it so that way they can respond before WebAssign closes out. And that's not what it's about. It's about you understanding. Because with all of this going on, we have to be very, very careful, because I don't want a bunch of you in calculus next year if you don't belong in calculus or you don't have the background because the curriculum's not covered, for instance. That's just one scenario, okay? So this quarter especially, you guys are going to have to prove in math that you really know what you're doing, because you're being placed according to a prediction that we did in January, okay? And now because of this situation that we're in, we got to be very, very careful to make sure that the curriculums are covered in math, especially because everything builds upon the last thing you learned. So if you're going into a calculus class and you're not prepared for that class because you didn't get it because we didn't meet the curriculum, then there's going to be a big problem with your grades in calculus. Calculus is not an easy class. It's hard even for smart kids. So if you end up in there but you didn't get everything in the curriculum, then you're going to end up having some problems. So we don't want that, right? So it's my job to make sure that I get the curriculum covered so that way you're well prepared for wherever you go to next year. So anyway, keep that in mind and let me know if you need help. And like I said, just shoot me an email through Edsby and I'll be more than happy to help you. Okay, have a great day.